Alrighty, so this question here asks us to differentiate f of x equals 1 on x using first principles. Hopefully we can remember that first principle says f dash x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Applying that process to this function here gives us the limit as h approaches 0 of f of x is 1 on x, so f of x plus h is 1 on x plus h, minus f of x, well f of x is just 1 on x, so that's that, all divided by h. Alright, the next part is, okay, so the tricky part about this question is that we need to realize that we need to get common denominators in the numerator so that we can simplify it down, or at least get it into a nicer form so that we can cancel out the h's. So if we do that, it means this x needs to be multiplied into the numerator here and the denominator here, and this x plus h needs to be multiplied into the numerator and the denominator there. So that's going to give us x on x times x plus h minus x plus h on x times x plus h. So that's just finding a common denominator by multiplying the denominators and the numerators. So divided by h. Okay, so in the numerator, sort of the double numerator on top of in this top part, we're going to get x minus x plus h divided by x times x plus h, all divided by h. Okay, now we keep going, so we get the limit as h approaches 0 of, well, x minus x, and remember this minus gets multiplied into that h as well, so it's minus h. So I'll expand that out just so you can see. So it's x minus minus h, all divided by x times x plus h, all of that again divided by h. Okay, we're almost getting there. X minus x is 0, so we've got a limit as h approaches 0 of minus h on x times x plus h, all divided by h. We're almost getting there if we head over here. Okay, so we've got f dash x, if we equal to the limit as h approaches 0 of negative h on x times x plus h, and then we're dividing everything by h, which is the same thing as multiplying by 1 on h. But instead of multiplying by 1 on h, I'm just going to realize that I'm doing that, and we'll put that h into the denominator over here, like this. So h is on the bottom there. So then what we have is this h now cancels with that, and we're left with the limit as h approaches 0 of negative 1 on x squared. If we expand the denominator, we've got x squared plus x plus h, plus x times h, I should say. Okay, now it's not so much a big deal if the h approaches 0, because that just means this term goes to 0, so that means we're going to have f dash x is equal to negative 1 on x squared. And that is our final result.